All right, it started. You guys want to say hi to someone?
Shut up, fifth period.
Seventh period, fifth period is graciously allowing me to record their lesson for you. So, you're a lot of people. Don't worry about it. All right, so we're going to do sine and cosine graphs today. We're going to do tangent and cotangent and secant and cosecant next Wednesday, not for Wednesday for you, Thursday for you guys. So, also, if you look at your assignment sheets, and you have a quiz next Thursday. So you have the quiz on this stuff that we're doing today. On Tuesday, you'll have extra practice, and I will have those packets for you guys, so because you don't have them yet. All right, so sine and cosine graphs, basically what we're doing is taking the unit circle, and we're unraveling it. So the unit circle, obviously a circle, we're going to unravel it where your x-axis is essentially your theta axis, okay? But we are going to deal with it in terms of x, so theta, we can say that theta equals x, okay? The sine and cosine functions, these are the parent functions, and you guys kind of recognize this a little bit from last year with your transformation graphs. You did them over and over last year with your shifts. Okay, you had H and K instead of A, B, C, and D. H and K, maybe ringing a bell. All right. So your A value is your amplitude, and that is half the distance. From the maximum and minimum. Oops. Okay. Your B value, that's your period. So it's how long it takes your entire graph to go through one cycle. So your period is always in terms of 2 pi. Sine and cosine graphs are always 2 pi, so it takes from 0 all the way around 2 pi, our unit circle. And sometimes your period can change by dividing it by the b value. So if you have a b value, you're going to take 2 pi divided by b. And that's the number of times the graph goes through a cycle. Bless you. Within one interval. So on our graphs, we're always we label our x values or our x-axis based on our period. So if our period is 2 pi, we're going to start at 0, and then at the end is 2 pi. So it's going to complete an entire interval in that 2 pi. So you can label your sine graph and your cosine graph at 2 pi, and then it would be negative 2 pi here. Okay, so what's the in-between then? So we start at 0, what would this first hash be? Pi over 2, yep. What would the second hash be? Pi. Are you recognizing all of those values? Okay. Your quadrantal angles from your unit circle. So one interval happens between 0 and 2 pi. Okay, your C and D values depend on your shifts. Your C value is your phase shift. And just like in transformations from Algebra 2, it kind of does the opposite of what it says. So if it says x plus C, it's actually moving to the left. And if it's x minus C, it's moving to the right. This is your phase shift. And D is related to, you can think of your K values from your transformations last year. Your K value was your vertical shift. So your D now is if it's positive, it moves up. If it's negative, it moves down. Right, if A is negative, what do you think about what happens to the graph? It's a reflection, exactly. Reflection across the x-axis. Okay? Okay, going back to our actual graphs, these are going to be your parent graphs, your sine x and your cosine x. We'll talk about those. Go ahead and label. I'm going to make this a little bit bigger, so I'm going to do 4 hash marks is 1 unit, just so we can actually see it. And then go ahead and label the negative x-axis. Okay, so what you're kind of thinking of, we'll make a table of values for this first one to think about. Our x values, we figured those out. We're going to start at 0, and then we have pi over 2, and pi, and then it'll keep going. So if you think about your unit circle, what is your value of sine when we're at 0? You should have your unit circle values for this too. So this will go a little bit quicker if you have those on. At sine 0, what is the value of sine 0? It is 0. So we have the point 0, 0. And what about at pi over 2? What is the value of sine pi over 2? That is 1. And that is your amplitude. So if your amplitude changes, you're basically just multiplying this y value by that amplitude. So in number 3, your amplitude is 3. So this value would still be 0. This value would be 1. And then we keep going. What about pi? What's our value of y? We go back to 0, correct? Okay, and then at 3 pi over 2, negative 1. And at 2 pi, back up at 0, right? Okay, so this is one cycle of your sine graph from 0 to 2 pi. After that, it just repeats. So it's just like it goes around the unit circle, it continues around the unit circle, it just repeats. Okay, so going backwards, and you can think about if we have our unit circle, we just went around going this way. What about going the opposite way? What is the value here? It's negative pi over 2, right? So what's the value at negative pi over 2? It's going to be the same as 3 pi over 2. Negative 1. So then what's the value at negative pi? 0. Oh, what is that? I didn't want to do blue. I mean green. I wanted blue. My bad. Okay, and then at negative 3 pi over 2 would be the same as pi over 2. So we're back up at 1. And then back down at 2 pi, which is another cycle. So we went the same exact thing. So you're graphing from, you're always graphing 2 periods. Okay? All right, go ahead and do number 3. Oh, let's talk about your period and amplitude. So your period, we did 2 pi. And your amplitude was 1. So looking at number 3, what's your amplitude? What changed? Your amplitude's now 3. Did anything change with your B value? No, so it's just 2 pi, correct? Okay, go ahead and label your axes, then graph your 3 sine x. All right, check your number 3 graph. Y equals 3 sine x. Amplitude is 3. Period is 2 pi. It looks very similar to our first one, right? Okay. The difference is that now our amplitude is 3. So we're really just multiplying our y values from our original sine graph by 3. Okay? Questions on number 3? We're all good? Okay. Let's go up to cosine. Alright, cosine, the amplitude for this one, again, is 1. And your period is 2 pi over b. Your b value is 1. We don't have any change in our interval. Okay, labeling your x-axis again. We've got pi in the middle, pi over 2, 3 pi over 2. Okay. Now, this time we're going to think about our cosine values. So when you're looking at cosine of 0, what's the value of cosine of 0? It's 1. Okay, what's your value at cosine pi over 2? It's 0. Cosine pi? -1. Cosine 3 pi over 2? 0. And cosine 2 pi? Back up at 1. Okay, so this is 1 cycle. Okay, going the other way, we basically just pretty much have a reflection. So at negative pi over 2, we're at 0. At negative pi, -1. That's too odd. Okay, here's 2 periods of your cosine graph. Yeah.
So why do you put the 1 and the -1 where they are? Like, are they at like a specific point, or are they just kind of
What?
like on the y-axis, the 1 and the -1? Why were they?
Why am I giving 4 hash
Yeah.
marks? So I have it separated. It would look really small if I just did it here. You can.
Okay.
Absolutely
so it doesn't really
can.
matter. Like
Yeah, so when I like grade your quizzes or tests, I'm gonna look at what you did as your y-axis.
Yeah.
So like number 3, I changed it because I had to fit 3 on there instead of just 1. Yeah. Okay. All right. Parent functions of sine and cosine. Are we okay? Okay. Any questions? Good question. I'll pause it. When we continue on to the next one, we're going to get different shifts. So I'm going to go flip over to your next page. Okay. Now number 4 has cosine 4x. So what's actually changing here?
The amplitude.
Not our amplitude.
Oh, the period.
It's the period. It's the b value. Okay. So we're going to do this. I'm going to do it one way on here. I don't want you to write anything down. And then we're going to do it the other way. And that's what I want you to write down. Okay. You can write down your amplitude and period. What's our amplitude? Our A value is 1. Okay, our period is 2 pi over our B value. Our B value is 4. So simplify your period. What happens? Okay, so what this is actually doing is saying that we're between 0 and pi over 2. All of what just happened for 0 and 2 pi is now going to happen between 0 and pi over 2. Okay? So so this is the one that I don't want you to write down, but I am going to label it the way that we had our other one. Okay, so remember for cosine, we were up at 1, then we came down. Oops. Okay, so this was our parent function, right? All right, so now, don't write anything down yet. Now all of these 4 points, 1, 2, 3, 4, are happening between pi over 2. So we're starting at 1, we come down, go down to 1, come back up. Okay, so this is happening 4 times as fast, so this is going to keep going and repeat itself until 2 pi. Now, I don't need you to draw it that small. What we're going to do is change our x-axis to match our period. Okay, so this is the graph I want you to make sure you write down. Okay, what you're going to do, our period is pi over 2. So from 0 to pi over 2, that's the interval I want you to deal with. So when we're done, our graph is actually going to look the exact same as that original cosine graph we did. The difference is that our interval is 0 to pi over 2 instead of 0 to 2 pi. Okay? So when we look at pi over 2, if we go half that distance, what's this value here? Pi over 4. Now labeling your other hash marks, and I do need you to do this. Half of pi over 4, what's this value? Pi over 8. So each hash mark is an 8. So we have pi over 8, 2 pi over 8, which simplifies to pi over 4. Then we have 3 pi over 8. And your last one is 4 pi over 8, which is the equivalent of pi over 2. Okay? Now all you have to do is just put your values in the exact same spots they were. They're different values now, but they're going to look like they're in the same spot. So cosine, we start up at 1. We go down to pi over 8. We go down to -1, and we're at pi over 4. Back up to 0 for 3 pi over 8, and back up at 1 for pi over 2. So that interval that I drew before is now happening. Now we've just made it bigger so we can actually see. And then it's going to happen 4 times by the time it gets to 2 pi. Best reaction ever, Oliver. All right, going the other way. Just make sure you label these so I know as you're going what your interval actually is. Okay?
Why is it going up and down like that now? Wouldn't it like slowly rise and then slowly fall over like the course of all 4 then? Because when the cosine.
It's going to go all the way up to 1. Our amplitude is 1. Yeah, so yeah, exactly. We're zooming in on that interval of 0 to pi over 2. Alright, so I've asked you guys to start number 5, so before we get too far in it, let's make sure we have our period correct. First off, what's your amplitude? No! Your amplitude is just 2. Your amplitude is 2, but it is a reflection. Okay? Now, your amplitude is never negative. And if you mark it negative on a test or quiz, I will just cross it off and say wrong. Okay? Not even partial credit on that. Okay? Your period is going to be 2 pi over your B value. So what's your period? 4 pi. So now we're happening half as slow. It'll take us between 0 and 4 pi to make one interval instead of 0 and 2 pi. Okay? So each hash is just a 1 more pi. Okay, go ahead and graph the rest. All right, take a look at your graph. How'd it go? Pretty bad. After looking at it, how's it going? Better? Okay. All right, our amplitude was 2, so we went down 2 instead of up 2 because we have that reflection. Okay? All right, do you think we can get to the shifts before lunch?
No.
I heard more yeses than I heard no's.
No.
Lunch is in 10 minutes, we got plenty of time. Yep, we're going to do it. We're going for it. We're going for it. Power. All right, number 6. Ooh. 8 and 9 are fun. All right, number 6. What's your amplitude? What's your A value? 1. What is your B value? What is your B value? All I want is your B value, not the rest of it. Your B value is 1, so it's just your period is 2 pi. Look on your front. If you don't remember your parent functions, write them down on the other side. Your parent function is y equals a sine b parentheses x plus c plus d. B value, what's your B value? Just 1. Okay? With that said, now what's your C value? Positive pi over 2. See that your phase shift will be to the right. It is opposite of what it says. So we're going to go right pi over 2. All right, go ahead and label your axes. Okay, and what I want you to do is draw your original function. That will help you see where the transformation is going, okay? So your original is this. We're going to go... Oh, what happened to my marker? No. All you're going to do now, my dashed red is my parent graph. Okay? So all we're going to do is shift our entire graph pi over 2. Okay? And that, for this one, is relatively easy because each hash mark is pi over 2. So just start at negative 2 pi, and you're going to shift it to there. Right? Go to your next point. Shift it pi over 2. Your next point. Now, you have 5 more minutes to lunch. Okay, now this is, why aren't you working again? If you look, everything, oh my gosh, technology's not my friend right now. If you look at everything that we marked, we have a full interval of 2 intervals. No, we're off by 1. So where would this point that was on negative 7, but it would be down 1 exactly. Okay, so you want to do that down 1. Okay. Still not working.
Why was the period
Still not
2 pi?
Excuse me?
Why was the period 2 pi?
Because the b value is 1. B value right here. What's in front? What's between sine and the parentheses?
It was non-existent, so it's pi over 2. Yeah, no, so it's 1. Yeah, no.
So 2 pi divided by 1 is
1. 2 pi divided by 1.
2 pi. So that's why your period's 2 pi. Does anybody have questions on 7? How did we do? Did we get there yet?
Close.
Okay. These keys are on Blackboard, so like I said, 6, 7, 8, and 9, you will be doing more on Tuesday. So look at the shifts. I always find it easier if you graph the parent function first, because then you can just take each point and shift it to where it needs to go. The frustrating thing with number 7 is that it's pi over 4. So each hash mark is pi over 2, so we have to kind of create these extra hash marks to make it pi over 4. Does everybody understand what is going on? Focusing on Oliver putting his class t-shirt on and stuff.
Oliver.
Alright. Looking at 8 and 9, I'm just going to touch on these, and then you guys can attempt them on Tuesday, and then we can talk about them before your quiz on Thursday. The biggest thing with 8, what does it appear that your B value is right now? What's that? Your B value is 1/2. Okay, but right now, there's nothing in between sine and the parenthesis, right? So we've got to factor out this 1/2. Our parent functions just have x plus c. There's no coefficient with that x. So you have to factor out whatever the coefficient of x is. So what you do with 8 and 9 to see what your b value is, you're going to factor out the 1/2. When you factor out 1/2 out of pi over 2, what do you get? Pi. So now you have all of your A, B, C, and D values. Okay, does that make sense? Okay, so you'd have to do the same thing for number 9. And you'll notice something about 8 and 9 when you graph them. They'll look quite similar. Okay, let's do number 9. Factor out that 2, because our B value is 2, so we've got to put it in its spot. What happens when you factor out 2 out of pi over 2? Pi over 4. Okay, so now this form allows you to have your A, B, C, and D values. Okay? Alright, I don't want you to focus too much on those right now. You'll deal with those on Tuesday. Okay? Alright, you are free to work on your classwork and homework. Okay, the rest of the time is yours, so please use it wisely.